All right, so I think this is recording. Let's take a look here at this problem. We have a polynomial. It looks to be in standard form, 4, 3, 2, 1 in constant term. The degree is the largest exponent on a variable, which is 4. 4 is an even number, so that means the end behavior is going to be the same sign. So it's not going to be opposite signs. So immediately when I see that it's even, I can rule out these two cases. The leading coefficient is 1. Yeah. And 1 is a positive number, so I know it's going up to the right. So as x goes to positive infinity, so does y. So it's going to be 1 there because they're both going to be positive or both going to be negative, but since it's going up to the right, to the right is positive, so they both are positive. If we let x be 0, then we'll be on the y-axis at 8. So that has coordinates 0, 8. And we'll see when I return that by looking at the factors of the leading coefficient and the factors of the constant term, we can generate a list of possible x-intercepts, possible zeros of this function. Now, it could be that our zeros are irrational numbers and they won't be in this list. But if it does cross an irrational number, it'll guarantee to be one of these numbers. All right, so let's start out, rather than starting out with large numbers, I usually try to start out with the smaller numbers just because it's easier to do arithmetic on. And I could do synthetic division or simply plug it in. For 1 and negative 1, I'll just simply plug it in. So for 1, it'd be 1 minus 1 minus 6 plus 4 plus 8. And that's not 0. What about negative 1? 1 plus 1 minus 6 minus 4 plus 8. And that is 0. Because the 1 plus 1 is 2 and 2 plus 8 is 10, and that's minus 10. So we found it there. So although plugging it in helped me identify the 0, it doesn't help me to factor this unless I do synthetic division. So we're expecting a 0 remainder. And that's what we get. But this is an x to the third, so we don't have any way to factor it other than we could. It looks like we could factor it by grouping. Let's go ahead and do that just to be different, just to illustrate that. You've seen it once before on a previous homework. This guy gives us x cubed minus 2x squared minus 4x plus 8. So sometimes, definitely not all of the time, you have this quadratic, this cubic, where it's set up that we can come in and write this in a table, but we just write it in our table from left to right. And now we factor both horizontally and vertically. So we get this. Now, like I say, that's not going to be, that's going to be a limited time. Most of the time, you're not going to be able to do it like that. And in a few of these, you can, just because they were set up to be kind of easy. If we set this equal to 0, this x squared minus 4, we can continue to factor it to x plus 2 times x minus 2. And notice that we have two factors of x minus 2. So we've got one there and one there. So let's now complete our table. So we've got x equals -1, x equals -2, and x equals +2 are the zeros for this polynomial function. The 0 at -1 has a multiplicity of 1, which means it crosses over the x-axis. The 0 at -2 has a multiplicity of 1, and that's an odd number. Both of those are odd numbers. But here, the 0 at x equals 2 has a multiplicity of 2, and that's an even number, so it's a touch. All right, so I hope that helps, and I'll talk to you later. Bye.